Batteries have been around a while, but for vehicle electrification, it's complicated. Who manages integration in the vehicle? How do you develop batteries without a close understanding of the application and the integration? Who's the integrator?
Typically, the OEM does the final integration, but they provide a specification. I don't think it's as complicated, actually. I come from an electronics background, and I would tell you that doing an engine management system is much more complicated than interfacing a battery to the car. We have a voltage requirement, a power requirement. There's maybe 4 or 5 key metrics that we look at, but at the end of the day, it comes down to how much power and energy can you package to hit the voltage that the motor requires that's being used in the car. Of course, there's diagnostics and communication that goes on between the vehicle and the battery that is somewhat specific between different OEMs, but I think engine management systems are much more complicated from an interface to the vehicle than a battery system is.
Nancy, is that an easier job?
Well, you know, I think what we see, just your question back on, you know, who's the integrator, I think what you find is if the company is making electrified transportation a significant part of their product portfolio, you will see, first of all, just as GM or Ford or others, there will be the integration of the insourcing of the battery system. It's a large component, it's part of crash, it's part of energy management, it's part of the package, it's the feasibility, it's the tie-in with the other systems. So that battery system and the fundamental software that drives that and integrates it to the vehicle, as the OEMs take on the responsibility or add to the product line of electrified, you're going to see that insourced. I think we've already seen that pattern. Battery cells then become, okay, how do we remain flexible to that cell technology, working very closely with the cell manufacturer, the characterization, so that together you can then integrate new or different evolving cells, which may roll far more rapidly than the car, but it still has to work in the rest of the vehicle. So, you know, I think
it comes down to whether you're talking about a system integration or a cell integration. I answer from a systems perspective, Nancy answered from a cell perspective. Every OEM is taking a different approach to doing the systems themselves or not. We're going a blended approach. So as you look at OEMs globally, typically we see major OEMs using a blended approach where they do some systems themselves. Of course, they want to understand the technology and what goes into it. At a systems level, again, I don't think it's extremely complicated. If you're buying cells and creating your own systems, yes, the battery pack is an extremely complicated system.
Another battery question.
You know, from my personal experience and perspective, the battery pack is called Bet Your Business. It's expensive. Call it $5,000. These days, call it $10,000. And by the time you have a warranty, you have to have product out in the field, you have to have service capability, you have to have markups, people have to make money. It's almost I can give you a new car rather than service your battery pack. So the amount of knowledge that has to go into taking care of those, think about what the volt's gone up and said and done. We're going to warranty that for 8 years. Now there's a lot that went into it by having your battery pack bigger than you need and only using like about half, actually about 60–65% of it. To give it life, $25–30 million test facility, so you can correlate what happens at the pack level to the cell level, and a materials lab so you can tear it apart and see what happened and how to prevent it. A lot of knowledge has to go in there because sooner or later the OEM holds the bag called the customer and a warranty. So is it complicated? It's not so much complicated as you have to be awful thorough and awful complete in what you do. So it's not a matter of, you know, wizardry. It's a matter of a lot of hard, long time, expensive lab work to get it done.
Another battery question, then we have some others. If the size of the lithium-ion battery market is $14 billion by 2016, what do you predict the cost reduction will be by that time?
Well, I think Nancy addressed that. I think most everybody would concur in the industry today. Prices are for an EV battery, and this differs from HEV. We don't measure HEVs in dollar per kilowatt hours, but in an EV or a large plug-in hybrid, the prices today are somewhere in the $750 a kilowatt hour range, and that definitely will be reduced in half over the next 3 to 5 years. And we believe $350 is probably an achievable level, you know, in the near term over the next 10 years.
I like that word, definitely. Remember that. Can electric cars, this one was specifically aimed at Nancy, but there's a broader question. Can electric cars be adapted for one Ford strategy globally, ranging from Lincoln to Ford brand globally and F-150 trucks?
Well, you know, I think first and foremost, you still have to be customer driven and meet the functional requirement and need that the vehicle is providing. So full battery electrics, if there's the miracle battery that then has all the energy and the power and everything else, the answer is yeah, probably. We don't know about that miracle battery. So I would say that the electrifying our highest volume platforms, the C-size sedan or C-size vehicle platform is the highest volume platform in the world. That is followed by the B-size, which is smaller. North America is somewhat unique in the truck applications. And then larger vehicles to meet load, tow, and all of the other requirements necessary. So this is why our One Ford strategy is around electrifying the highest volume platforms, customer-driven applications, but still deliver the functional need. So we still see absolutely adequate room for EcoBoost, petrol diesel solutions, or hybrid solutions for the load tow requirements going into the future. Having a truck that can't do what a truck needs to do is not going to work for the consumer. It won't be a value proposition. So I think our strategy is quite pragmatic, and it's going to be focused on putting and electrifying at the appropriate level in each of the segments as we move forward.
A somewhat related question. The EV1 was a very purpose-built electric vehicle. Later we're going to hear from Paul Wilbur at Aptera. That's an extremely purpose-built electric vehicle. Same time we're coming out with a new Focus EV. Should battery electrics be purpose-built or on more common platforms with internal combustion cars? That's both John and Nancy.
Well, I think our view is, as we've said, we're going to electrify platforms. We see the battery technology has to go through a tremendous evolution to continue to shrink it and help on its affordability. So we see a certain percentage of customers that BEVs, the full battery electric vehicle, is a great match. That's a small proportion of the population. And by electrifying the platform, we're giving the consumer the choice of the hybrid, the plug-in, and the battery electric. I'm also avoiding, and as a corporation, we're avoiding unique platform investment, continuous care and feeding, unique top hat, all of the things that comes associated with the value proposition, delivering that value proposition and the cost. So by building it down a common line, having the flexibility, depending on fuel prices, customer demand, acceptance of the technology, incentives, disincentives, wherever the government may be going, we have the flexibility to adjust very rapidly. At the end of the day, a non-viable business equation will squash electrification.
So it's optimizing coefficient of drag, optimizing mass.
Reducing weight, improving C-system, delivering all of that, which by the way helps all of the power packs and reduces energy consumption across the board.
John, purpose-built versus common platforms.
Well, if we take a look at the EV1, and there was no nickel metal hydride, there were no lithium ion, it was laboratory stuff. We had recombinant lead acid in those days, and it's pretty heavy stuff. So what the EV1 was all about was first the world's most efficient production vehicle. Mind you, small volume production, but nonetheless, it was all about the vehicle, about the aluminum structures, the use of magnesium and the like. It was all about the least amount of energy to move it down the road, so we could get that 100 miles. In fact, I think we got 106 miles with some good recombinant lead acid batteries. So the idea there was to put the money into the vehicle in those days, strategy-wise, as opposed to put it into unobtainium batteries in those days. Now, the world has changed quite a bit, as we've seen here in all our presentations. But what would the future state be?